Now we already know how we can distinguish an acid from a base using several indicators like litmus paper and other indicators. Now, can we distinguish between a strong acid, or can we say how strong or weak an acid is, or how strong or weak a base is? Yes, we can do that by finding the concentration of H plus ions in a solution or hydronium ions in a solution using a universal indicator. So, what is a universal indicator? A universal indicator is a mixture. So, it is a mixture of several indicators. Now, in this universal indicator, we get different colors depending on the concentration of hydronium ions in a solution. So, depending on the concentration of hydronium ions, now we know that an acidic substance, an acid contains H plus ions, but in a solution, that is in a water solution, when it mixes with H2O, it forms hydronium ions, which is H3O plus ions. So, if the concentration of H3O plus ions is more, that means the substance will be more acidic. If it is less, that means the substance will be less acidic. And we use a universal indicator. And the universal indicator shows different colors depending on the number of hydronium ions. Now, you can see a word pH, a term pH. Now, pH is Now, pH is used to denote how acidic or how basic a substance is. So, observe P is written in small and H is written in capital. This is how you will always write pH. P in small and H in capital. Now, what does P stand for? P stands for potens. It is a German word which means power or potential. So, it is a German word which stands for potens, which means power or potential. So, P stands for potens, which is a German word which means power or potential, and H stands for hydrogen. Means we are looking for the power or potential of hydrogen ions. So, in the pH scale, pH stands for potential of hydrogen. It is a measure of concentration of hydrogen ions. 7 means the substance is neutral. Less than 7 means it is acidic, and more than 7 means it is basic or alkaline. 0, so as we move away from 7, the substance becomes more and more acidic. As we move towards that side of 7, the substance becomes more and more basic or alkaline. 0 stands for very acidic and 14 stands for very basic. So, what does pH stand for? Potential of hydroxide, potential of hydrogen, or potential of hydroxin? Well, pH stands for potential of hydrogen. Now, let us look at some substances and we see what color they give with pH paper. Now, what is pH paper? pH paper is coated with universal indicator and it shows different colors for different substances depending on the concentration of its hydronium ions. So, by looking at the color and by looking at this pH chart, we can decide whether the substance is acidic, neutral, basic. Also, whether it is slightly acidic, strongly acidic, a weak base, strong base. So, depending on this color chart. So, we use a pH paper. Now if we look at saliva before meal, that is before having our food, we see that it is slightly green in color. So now slight green means somewhere here. So we can say that the proximate pH is between 6.5 to 7, and we can say that it is slightly acidic to neutral, because 7 stands for neutral. If you go towards left from 7, it becomes more and more acidic. If you go towards right from 7, it becomes more and more alkaline. If you look at saliva after meal, we see it is slightly yellow, that is somewhere here. So we can say that the pH is between 5.5 to 6.5, that is, it is slightly acidic. So we can say that after meal our saliva becomes slightly acidic. If we look at lemon juice, we see that it is red, orangish red. So we can say that the pH is between 2 to 3 and it is acidic. We all know that lemon juice is acidic. Colorless aerated drinks, that is soda. So if we see the pH, we will see it is orangish red, yellowish orange red. So we can say that the proximate pH is 3 to 4 and it is acidic. Carrot juice, we see that it is yellow in color. So if we dip pH paper in carrot juice, we will find that we get a yellow color. So somewhere here the pH is between 5 to 6 and it is slightly acidic. So as you can see, we are getting approximate values of pH based on the colors. Now if we look at coffee, we see once again we get a yellow color. So somewhere here the pH lies between 4.5 to 5.5 and we can say that the coffee is acidic. Tomato juice, we see that the color is orange, the color of pH paper becomes orange. So over here, so the pH is 4 to 4.5 and it is acidic. Tap water, if you dip pH paper in tap water, we get a green color. So we can say that the pH is 7, tap water is neutral, it is neither acidic nor basic. If you look at 1m NaOH, 1m means 1 molar, that is 1 molar NaOH, 1 molar sodium hydroxide. We get the color as deep purple, that is here. So we can say that the pH is 14 and it is strongly basic. We know sodium hydroxide is a strong base. So pH paper gives a color of deep purple. So pH is 14 and we can say it is strongly basic. Similarly, 1 molar hydrochloric acid, it will give a dark red color. Somewhere here a dark red color. So the pH is 0 and we can say it is strongly acidic. So 1 molar hydrochloric acid is strongly acidic. So now let us look at some more substances from our daily life. Gastric juice, the pH of gastric juice is about 1.2, somewhere here. The pH of lemon juice is approximately 2.2. The pH of pure water or even blood is 7.4. So the pH of tap water is around 7, but the pH of pure water is 7.4 and that of blood as well. Milk of magnesia has a pH of 10 and sodium hydroxide solution has a pH of 40. So this is how we use the universal indicator and the pH paper to find the pH of different substances and infer whether they are acidic, basic or neutral, and whether they are strongly acidic or weakly acidic, strongly basic or weakly basic.